Hi and welcome back to a new video. Today we will be looking at the new EK Nucleus Direct-Die-AiO, which is a very obscure product in itself, for multiple reasons. Direct-Die with Intel is not possible with usual AIOs, simply because the chip of the CPU is sitting a little bit lower than the rest of the plastic socket around it. I will show you what I mean later on with this setup. So it requires a special treated and shaped base of an AIO, a cold plate, to make sure that it's possible to mount the CPU on the CPU, which is something that EK did. And that is kind of strange because typically you would only do Direct-Die if you're really going for the last few degrees Celsius, which is something that you usually do when you have a high-end custom water cooling solution. So that's why it's pretty odd that you would do something like this with an AIO, because the AIO is not the best possible cooling solution. But at the same time, EK says that this performs exceptionally well. That is something I want to find out in today's video. This video is powered by Seasonic with their MagFlow fans. These non-RGB fans combine both a low noise level and at the same time high airflow. In addition, they come with the perfect daisy chaining cable management system. Depending on your requirements, you can connect a different amount of fans directly with each other. For example, 2 or 3 fans for water cooling on a radiator. The fans are held together with a magnetic system which is extremely strong and also electrically connects the fans. With additional adapters, you can extend this even further. So for example, 2 fans on top of your PC for the AIO and a 3rd fan as case exhaust fan. Find out more about Seasonic's MagFlow fans in the description below. We will compare the AIO versus this setup, which is the Corsair A115 air cooler that is sitting on an Upgrade Heatspreader. That means that underneath the CPU has already been delivered. It's a 13900KS. At the same time, this AIO is LGA 1700, which means that theoretically the CPU AIO would be compatible with 12th, 13th and 14th gen. Right now I only have one 14900K and I don't want to delete it right now. And that's why I will simply go with this comparison first with an already deleted 13900KS. And then it will just depend on your feedback if you want to see additional testing. Maybe you want to see it versus custom water cooling. And then we can do that in a follow-up video. The kind of good and maybe sometimes also bad thing about the 13900KS is that it boosts as high as possible, mostly thermally limited. That also means whenever you have a good cooling solution, the CPU will benefit performance-wise. If we run Cinebench R23, we can see that the CPU with this current cooling solution, which is also the CPU deleted, consumes about 330 to 340 watt. And you can see the CPU is always thermally limited, so always hits about 100 degrees Celsius. And if we look at the clocks, we can see clocks somewhere between 5.4 to 5.6 gigahertz, which then results in a score of 38,300 points. As a second comparison value, I now tuned the CPU to a fixed clock with a fixed voltage, simply so we can easier compare the temperature under load, even though it is slightly lower performance than stock. The CPU is clocking at 5.3 GHz with a voltage in BIOS set to 1.32 volt. If we check temperatures, but also check the power consumption first, which is about 270 watt, we want to note down the maximum temperature after this run, which I will then make an average of, and that is going to be our comparison value, the second one for the AIO. The air cooler was just mounted on this Upgrade Heatspreader, which is very similar to the AM5 Upgrade Heatspreader that we have from Grizzly. This is still a prototype product. It is already evaluated and confirmed that the performance is really good, but not yet a final product. But that's just what I used for this testing. And that's how this heatspreader looks from the inside. To solve 2 problems, have good contact to the die, but at the same time also have sufficient pressure into the sockets to make sure that things like memory clock and anything like that is not negatively impacted. And the thing is, as usual, if you would try to mount any kind of AIO on this right here, it would sit on the edges of the plastic socket, which is slightly higher than the chip in the center. So that's the first problem, that thermally you wouldn't have good contact, and at the same time it wouldn't provide any kind of pressure of the PCB into the socket, which is causing a lot of problems for PCIe and also, let's say, memory detection. And this is why that's a special version of the EK Nucleus Direct-Die, which you can also see by the skull. And thus, with the special cold plate, it should make perfect contact to the chip. One thing I definitely like, and that's that conducting out liquid metal is included. And as additional reason why the mounting should be very effective, we have this back plate right here. And on top goes this mounting plate that presses down the CPU into the socket. And again, this is building up additional material that would be in the way for mounting of any normal AiO. Which is again the reason why the cold plate of this EKAiO is shaped exactly this way. To just go in all the way in the cutout and make contact with the die. And also for full transparency, because you probably have spotted that my logo is there, like EKX, the Bauer logo. And that is mainly because those are the same parts that were used back then, like a year ago, when we had a co-op on the custom water cooling block for Direct-Die. And those are essentially the same parts, but there is no financial compensation from EK towards me for using the logo. It's the same way I do it with all those kind of corporations, same with the O11 Dynamic, for example, but definitely I will benefit because you could see there is the liquid metal included in the AiO. So if EK sells 200 AiOs, Thermal Grizzly sells 200 pieces of liquid metal. This would be the state ready to go with the CPU mounted with this contact frame into the socket. That's basically the same as what we already showed back then with the custom water cooling block. That's why I'm not going to repeat it so much in detail. And on that, I will now mount the EKAiO, where you can see I already applied fresh liquid metal onto the cold plate surface. And now the AiO is successfully mounted. Also, this is a swappable top. There is also a neutral one included, but personally, I'm a big fan of the skull. It definitely reminds me of the good old Intel skull trail. Now I'm very interested to see if everything works and what kind of temperatures we will see. At least visually, I think it looks like a very good AiO. First look is definitely good. We have all the memory channels detected and also the idle temperature seems to be good. 34 degrees Celsius, definitely an indication for at least in idle good contact. Starting with the same situation, we want to check what kind of score we can get in R23 and how much heat we can dissipate. Power draw is very similar with about 320 watt. Clock is a little higher with 5.6 GHz and also more stable. Temperatures are for sure about 15 degrees Celsius lower than previously. Seems like the score is also about 500 points higher, which is not too much though, but there's always some fluctuation here anyway. By the way, I adjusted the fan speed of the AiO to match the noise level of the A115 of Corsair, simply to have somewhat a comparison. So it's the same noise level in 40 centimeters distance. And now the second comparison setting with 5.3 GHz, so fixed clock and fixed voltage. The power consumption is a little bit lower, maybe like 5 or 7 watt, which is definitely caused by the lower temperature. As we can see, temperature dropped by maybe like 5, 6, 7, but I will have to look into the data and do an exact comparison. Definitely is lower and results in 38,500 points, so that's all in line. I just finished looking at the two data sets and it's incredible. It's much better than I expected. You will also notice that the line or the chart of the A115, the air cooler, is slightly increasing constantly, which is definitely caused by the fact that the air cooler will keep heating up until saturation. And the AiO is, for whatever reason, much more capable of keeping the temperature at the same level, which means that at the beginning of the comparison, we have a smaller delta than in the end. At the beginning, we were talking about 9 to 10 degrees Celsius, and in the end, about 14 degrees Celsius difference, which is insane. It's much more than I expected, because you have to keep in mind, the air cooler was already using this Upgrade Heatspreader, which will give you like 6 to 8 degrees Celsius already benefit over stock application, which would mean that we're looking at overall 15 to 20 degrees Celsius better results with this AiO Direct-Die than with the air cooler, which is probably plausible, but still a lot. And I think it's definitely necessary that I have to repeat this testing with custom water cooling and a custom water cooling Direct-Die block for additional data. At least that's what I think. Let me know what you think about it. If you want to see more data and what kind of data you would like to see, then I'm happy to retest this to give you more information. But first look, seems to work really fine and seems to output incredible temperatures. Also, if you look into the EK shop, it is listed at 200 euro, which I think is a absolutely fair price for what you get. There is a downside that, at least currently, from the current information, it will only fit at the current CPU gen, or like the older one, like 12, 13, 14th. But you probably cannot use it for newer CPUs, at least right now. We are not sure about the 15th gen. So that's one downside. You cannot really use it for any kind of future application, different CPUs, which is something you can usually do with AIOs. But apart from that, it seems to be performing extremely well. Well, let me know what you think and what kind of testing you want to see. If you want to see other testing, I'm happy to repeat it. Thanks for tuning in. See you next time. Bye bye.